Hello there, this is me again, Alan, and this would be lesson 7 in the series, whatever it's called. Last time I mentioned that I wanted to have a quick look at the addition operation, since we were looking at subtraction and we found that subtraction is just addition. If we can understand addition, then we would have everything, at least as far as plus and minus. But I did kind of leave you hanging a little bit with that carry flag, and I thought maybe a couple examples might help clear it up a bit. So I actually prepared a few examples, and I'll try and run them and see what happens. Now, I haven't explained to you how to do this, but when we're in the debug program and we're making up, some program, whatever, you can save your work off into a file called com file, .com. Into the command file, and so that's what I've done. Is instead of having to retype everything back in again, I've saved my work off into a couple files. So let's see now, which one do I want to look at? First, oh yeah. First, I just wanted to show you that this carry flag, the one that flowed over before in the last example, can be set with a single command, or cleared also with a single command, and that command turns out to be stc, set carry. If I run this, right now it's cleared, there's no carry. If I run this command, now it has a carry, and if I run clear carry, goes away. Set carry, clear carry. The other thing I noticed, let me go to a different spot. Suppose I put in, how about this? This is a good, we're in a lucky scenario here. Well, actually, how about this? Subtract from AX, nothing. Well, AX happens to be 0, so the result of the subtraction will be 0. I'm going to point to that instruction. So the result of that instruction will be 0, and if you'll notice here, there's another one of these flags which has something to do with 0, and right now it's saying not 0. So if I subtract and the answer comes out 0, if I do anything and the answer comes out 0, this should change to say 0. I hope it works. There you go. ZR means 0. I was trying to think of how can I set this flag, like I can set the carry flag with a single command, and I tried different things like, okay, set Z, didn't like it, clear Z, didn't like that, and I'm thinking, and trying to remember how did I must have, in my way back when I used to do this professionally, I must have had occasion to have to set the 0 flag. I couldn't remember how to set it. And then I thought, well, it's just a register, so all I need to do is somehow find out which bit corresponds to the 0 flag, and then somehow just set that in the register. And I couldn't remember. And I tried various experiments, and eventually I found out which one it is. It turns out that it's the 6th bit. So that means going over to our thing here in a 16-bit world. The 6th bit, this is 0, 1, 2, 3, 4, 5, 6. That's the one I want to set. So, and that's equal to 40. Okay. Well, the point of this is I want to be able to set the 0 flag, but I don't want to disturb all the rest of this other stuff. So one way to do it would be to somehow put a 40 in here, and then it should, so it's already set. I'm going to make it, it's easy enough to clear it. All I got to do is compare anything with itself. What? Compare AX with AX. The result of that, oh wait, no, that's just maybe 0 again. What I want to do is make it not 0. So in order to do that, it has to be a 1. Like, here's another new instruction. Increment. That's like, that's this, you know, like in C. Increment. Now this should turn it from being 0 to not 0. Alright? Now I want to make it, now if I want to make it 0 again, that's easy. I just compare AX with itself. Compare, or BX, doesn't matter. That should do it. See? But that was the problem, is that in order for me to change it from being 0 to not 0, I had to disturb something. But with the set carry instruction, I can just set the flag and not disturb anything. So then the brainwave, and then I found out about the 40, and I also recalled another thing, which is that, and then now I'm going to introduce yet another command. What you do is, well, actually, first let me show you my algorithm. Here's one way to do it without disturbing anything. I'll assemble it here. First, I'm going to use AX. So I want to save AX off somewhere. Now there's a command that allows me to save AX off far, far away and bring it back again after I'm done working with the registry. And that's called push. So I can say push AX. So now I've saved it off. And then I want to make AX 0. And one quick way to do that is to just XOR it with itself. XOR is, I don't know if you know what that means. Exclusive OR means either one is true or the other is true, but not both. So the effect of XOR of something with itself always makes it 0. So if I do that, that will make AX 0. Now I could increment AX, and that has the effect that I wanted. I wanted to make it not 0. And then to get the old AX back, I do this pop instruction. Pop pushes that AX away somewhere, pop brings it back. It's one of those last out, first in, last out type of thing. It's called a stack. Alright, Now that's going to work. I'm going to be able to change the 0 flag from what it is now, 0, to not 0, and I will not disturb AX. Just so that you really believe me, I'm going to put something different in AX. Okay? I don't want to lose all that information. So I push it away, doesn't matter where it went. It's gone somewhere. Make AX 0. Now all I got to do is increment it. Now I got my not 0. And I'm going to bring it back, but bringing it back doesn't disturb the not 0 flag. I brought it back, so I was able to change it from 0 to not 0 and nothing disturbed. But I thought that that's probably that's a lot of work you got to go through in order to set one little flag. And in fact, it is a bit too much work. But the other solution, another solution also uses this pushing and popping. Turns out you can push something onto the stack and you can pop it back into the flags. So if I wanted to set one of these bits, all I gotta do is take the flags I want, push them on the stack, and then use this special pop F command to pop whatever's on the stack, where I haven't explained where it is, but it's there somewhere, back into the flags. And what I want to do is make a 40 here. Well, I'm going to show you that that works, but it has a problem like everything else. I don't want to do that yet. So first I want to put 4. I have to save off AX again. I'm going to put 40 in AX and push AX, pop that back into the flags, and then recall the AX. Remember, that the first thing I pushed was AX, and then I did another push, and that was 40, and then I popped the 40 into the flags. Hasn't happened yet, and then I restore AX. So let's see what happens. Okay. Oh, I didn't show you, but I just executed the push. So we saved AX off. Now we set it to 40, push it up on the stack, pop it back, and there it is. However, here's the problem when we store AX. You'll notice that it's true that I changed the 0 flag, but some other things got disturbed as well. Like, we started with this. Something changed. Maybe nothing changed. Well, we got lucky. Because normally, if any of these other ones happen to have not the values that they have now, they would have been set to 0. Because all I did was I wrote a 0 on top of all the flags except for this one, because of 1. And so that method's not perfect. And I'll let you think about how to perfect that method. Now, what I really wanted to show you was more Broly. So now, I've showed you that there is a 0 flag, and you can probably guess what sort of comparison that might be used for. compare, subtract, see more. Oh yeah, okay. This is quick. So I want to show you now that using the compare has the same effect as subtraction in terms of the CY flag. So first I'm clear this off just in case. So I'm comparing AX, which is 2, with BX, which is 3, right? And I want to see if AX is less than BX, or greater, or whatever. And now, if I trace this out, actually, let me try. U means unassemble. Show us what command I intend to execute. I know that 2 is less than 3. So when I do this comparison, it should come out that the thing I'm comparing against, or the left-hand side, it's always the left-hand side that I'm concerned about, is below the right-hand side. So this should cause a jump to 115, or it does something else. So compare. You notice the carry flag got set. Now, you know, and I know, that this jump below instruction is nothing more than a jump if carry flag is set. So really that's what that's saying. They're fooling us by putting a B here and giving it extra meaning. But there you go. See, it worked. Now I've cleared off the carry flag again. I don't know why I'm resetting these. Oh, there's a reason. Because right now, I'm going to do the same thing, but instead of doing a comparison, I'm going to do a subtraction. Now, I've subtracted AX from BX, so that had the effect of disturbing my AX. But in terms of the carry flag, it has the same effect. So the jump below, whatever, it doesn't matter what's here. This part is going to get, or this instruction, this test will be true, and we're going to wind up back where we started at 100. See? We're at 100 again. So, the point of it all is that the compare instruction actually uses the same circuitry as the subtraction, except all it does is it does the subtraction, but it doesn't store the result. So it's a way of subtracting without storing. Maybe that makes it a little faster too. And the other thing, oh yeah, okay. This name actually has some meaning. I've been doing these jumps, jump here, jump there, hit left, below, This particular set of what they're called conditional jumps is composed of actually 4 different kinds of jumps. And I wanted to see which ones were which. So I'm going to list what they are over here. There's JA, which means jump if above. So if the answer to the comparison was above, whatever that means, it'll jump. And then there's JB, which means jump if below. Now these two, JA and JB, go together. Above and below sort of sound the same, to me anyway. Now the other two are greater and less. So there's jump if greater, which is the one, no, we've seen this one only. So jump if greater, and JL jump if less. Now here's the question. Why would you have 4 instructions to do the same thing? And the answer is because they're not doing the same thing. One of these pairs is a signed comparison, and one of these pairs is an unsigned comparison. That's what they mean when they have signed and unsigned numbers in C programming. Comparison, signed and unsigned comparisons have different instructions. So one deals with just the magnitude of the value, and the other takes the sign into account somehow. So I wanted to determine which of the two is the signed version and which is the unsigned. So to do that, I made a little test program. I'm going to look at it here. So again, I'm going to put two numbers in AX and BX. And here I'm comparing BX with AX. Now, actually, I don't want to use this one just yet. And this was actually step 2. If I had something else that had negatives in it, we'll just make up a new one. I'm going to try to show you which one is the signed and which is the unsigned. Okay, so in order to do that, we need a negative number and a positive number. Okay, so what we need is a negative here. So what I'm going to do is put into AX something negative, like -1, or take -1, and BX something positive. And I want to compare AX with BX. Now what I'm interested in finding out is whether or not the above versions or less versions, well, the two versions I had written down, I had to pause for a minute because I lost it. What we had was jump if above, sorry about this, jump if below, which is one we've seen a lot of. Save some time here. And then there's JG, jump is greater, and greater and less, jump is less. Alright, what I want to find out is which is the signed version and which is the unsigned version. I happen to know that they are broken up into signed and unsigned. This is why you get, well, if you're like me and you have the warning level on your compiler set to the highest level, you get all those warnings, signed and unsigned comparison. And what they're warning you about is the fact that it's going to be selecting one or the other of these sets of commands, and you might not get the answer that you expected. Okay, so how do we do that? Well, here we've made a comparison of, on the left, -1, or what we'll call -1 if it were signed, and 5. Let's trace through the first two, so it's all set up. So we're going to compare -1 and 5. Now the question is, going back here, first I want to know, I'm going to take two of the same category. Less and below are of the same category. And one of them is going to be true, and the other one is going to be false. So what I'm going to do is put both of them in. In the right spot, yes. So first, we'll do below, jump it below, make up a number, 120, say, and then less. So now I got these two conditions. Okay, fine. And then we can put something at 120 in a minute. Now, what's going to happen is one of these is going to be true. And what we want to do is figure out which one is the signed and which is the unsigned. Clearly, -1 is less than 5. So if it jumps, then that's the signed version. If it doesn't jump, that's the unsigned. But what if the first one jumps, then we don't get a chance to test the second one. So we could either rewrite the whole thing and reverse these two lines, or we can get a little clever. I think it's clever. Just reverse this set of comparisons. So now I'll put jump less first to somewhere. 10. I'd like to wind up back here again. So let's say 10C, and then jump it below to 10C. Now the two possibilities are this. If this one jumps, right, we don't know, we will know that this must have been a signed comparison. It took the sign into account. And then therefore the other one must be the unsigned version. But we don't know that for sure. Then it'll be at 120. And now it's going to run the one that the other one we wanted to test first. If it's true that they're opposite, that they behave oppositely, then this one will fail, and this one will succeed again, and we'll wind up at 10C. On the other hand, if this one doesn't jump, then this one should jump. And that'll bring us again to 120, which will bring us back to 10C. So either way we do it, both of them will get tried. And we should probably put something at 10C. And what do I want to put here? Well, what I'm going to put here is the command that exits the program. Don't ask me why, but that means exit program. Okay? So we've done a couple steps. We're ready to go. We're about to do the comparison. Now you'll notice that the carry flag did not change. So clearly, from our previous knowledge, we know that this one is not going to jump. So this must be the unsigned one. Jump if carry is unsigned. It compares magnitude, not signs. As you can see, it's not at 120, and now it's going to try this jump if less command, and it should go to 120. It did. And these flags aren't changing as we jump around, so this will still be a true condition. So that should take us back to 10C, where our exit program instruction is. By the way, this is actually a function call to a great big long function. So we don't want to use the trace command to go through it. We can step over this by just pressing P. It's like when you're in the debugger and you want to, they have step in and step over. P is step over. Proceed, it means. And there the program finished. So that showed us then that this is unsigned. And this is signed. Okay? Now if you go through the same exercise, you're going to find that both of these are unsigned comparisons. And both of these are signed comparisons. So now we've got that sorted out. We'll keep that. What else did I have to say? I think that's pretty close to everything I had to say. Oh, well, I won't go through this one. And in fact, I'll leave this for you to try on your own. I'll give you a little bit of a hint. Let's go back to where we were. What if I can put -1 here? That's good. Speeds things up. Okay. I'm going to run through this comparison. The carry flag doesn't change, but that's not the only flag in this list. You'll notice a bunch of other things change. Something called PE, which I don't know what that means. I think it's maybe, I don't know, parity or something. But this here, this one, this is called the direction flag, positive or negative. And you'll notice that this changed from positive to negative. The carry flag didn't. So it's my hunch that the jump if less test is really the same as jump if negative. I would guess, and I'll be as surprised as you if this works, but I'm going to try just typing in jump and JNG, jump if neg, and see if it thinks that's a jump less. And there it is. You see what I'm saying? It's so easy. You figure these things out. Nobody, you don't need the book. Reading it from the book doesn't tell you this bit, right? That this is exactly a test against the negative flag. So that's what jump JL is. Oh, and there's one more thing I want to show you. These little jumps here, you'll notice, as you try playing with this at home, have a kind of limitation. I'll give you an example. Suppose I try jump below to 300. I get an error. And why that? Why can't I go to 300? And the answer is the answer is contained in the fact that this instruction is only 2 bytes long. That is, the first byte is the instruction code, that's the JB part, and the second byte is some kind of parameter. So that puts a limit on how far away this thing can jump. And we've seen it go backwards and forwards. So clearly, the best it could possibly do is to jump about 128, that is 80 hex bytes, one way or the other. So I looked at this 72 instructions, and I wanted to find out, okay, well, what's the furthest it'll go? So I thought, okay, I enter in, we're currently at 108, a jump is below instruction in machine code, and I put what I think is the biggest number it can take. Alright, and what does it tell me? Oops, I'm in the wrong spot. Enter. I want to enter at 10A. 72FF. Well, look. It says the jump is below to 10B. And that's just 1 byte ahead of where we are. And worse than that, it's jumping right into the middle of its own instruction. So that's just garbage there. So obviously FF is not a valid argument. It shouldn't have let me put that one in. But what if I reduce this by 1, let's say. So we'll enter back in there. 108, 72, yeah. What does that say? That says jump below. Jump with the carry flag set to 10A, which is exactly the position we're on. Well, it's lucky that carry flag is not set. So what if I set the carry flag? Let me just go set the carry flag somewhere. So, yeah, I forgot where we were. 108. Alright. Oh, God. That's right, I ruined. But I remember the instruction. 72 F E. Enter to 108. 72 F E. Okay, we're ready to go. Carry flag set. And If I trace through this command, it's going to jump to itself. See? And that's about the tightest loop you'll ever see. This thing is dead. It's paused. If I press the proceed, try to proceed or go, it would just hang, stop. And that would be the end of the story. I would have to use a task manager to kill it. Anyway, I guess I'll get to the addition thing next time. This has gone on a bit long. So I'll see you then.